Okay, so let's start today's class. Today we are going to discuss about some unsymmetrical fault. Okay. So, what are the various type of unsymmetrical fault take place in the power system? Rahul? Hello. राहुल आवाज आ रही है? हेलो. So in power system, various type of unsymmetrical fault take place just like as a line to ground fault, line to line fault, or double line to ground fault. Okay. I think we already discussed about this problem of symmetrical fault also per unit. Okay. So today we are going to discuss about the symmetrical fault. So let's first of all share the screen and then we will continue our discussion. हेलो राहुल, आवाज आ रही है कि नहीं? Unsymmetrical fault in power system. Fault current calculation. So we already classified that various type of unsymmetrical faults when we discuss the symmetrical fault. Okay, that means line to single line to ground fault, double line fault, or double line to ground fault. Okay. So today just we are going to discuss single line to ground fault. Okay, single line to ground fault. That means whatever we assume in the symmetrical fault current calculation, that means when the fault take place, we assume that the alternator at no load condition. Okay, that means no load current flow or supply through the alternator. Okay, so we discuss about the alternator. So we just draw the alternator systematic diagram that is represented here in 3-phase. So if we consider here 3-phase circuit diagram of the alternator, that you may be phase represented as RYB or ABC, whatever you maybe want. Okay. So 3-phase, that means here we just indicate by phase R, phase Y, and phase B. Whenever the EMF induced in phase A, R is represented by ER, and EMF induced, is it visible? Hello? So EMF induced in phase R is represented by ER, and their impedance is represented by here Z for phase R, phase Y, and phase B. That means all 3 phase impedance are equal, that is represented by Z. Okay. Whatever the current flow through the respective phase RYB, that is represented by IR, IY and IV. Okay. So all the phase current is just represented by their summation of the vectorial summation of the zero sequence current, positive sequence current and negative sequence current. Okay. That is positive, negative and zero sequence current represented by a suffix 1, 2 and 0. So I present here phase current, that means IR equal to summation of the vectorial summation of the positive, negative and zero sequence current. Okay. That is represented by here. So that phase current IR equal to summation of positive, negative and zero sequence current. IR1 IR2 plus IR0 IR0 plus IR0, that means zero sequence current. IR0. So the neutral point of the alternator is connected through the ground with a impedance of Zn. Okay, represented by Zn. So this neutral point is connected to the ground. So can the zero sequence current flow in the alternator if the neutral point is grounded. Okay. Okay. And all the respective EMF induced in RYB is shown here. That is already try to mention here also. So that means EMF induced in phase R is represented by ER EMF induced in phase R is equal to EMF induced in phase R. Similarly, EY and EB is EMF induced in phase Y and phase B. EMF induced in phase Y, that is represented by capital E suffix Y, equal to EMF induced in phase Y here in phase R, and EMF induced in phase B is represented by E suffix B. suffix B, that means EMF induced in phase B. Okay. So now the fault takes place in phase R. So at this point, suppose that that fault current is represented by IF. Okay. So since systematic diagram, fault IF represent the fault current. IF equal to phase current IR, whatever the current flow through the phase R. Here IR is equal to phase current of R phase current of R or fault current, or we maybe say that fault current because the fault takes place in phase R. Okay. Fault current. And Z is your phase impedance of RY and B. Z is represent as the impedance of equal to phase impedance of RY and B. Y and B. And Zn is your neutral point grounded with impedance Zn. So before that, this phase voltage is represented by VR because this phase voltage, okay, and this one is your Vy phase voltage with respect to neutral, and this one is your phase voltage V with respect to neutral, that is phase voltage. Okay, and IR, IY, and IV, whatever phase current of RY and B respectively. So just write here IY and IV and IB is your phase current of phase Y and B. Okay. IB equal to phase current of Y and B, phase Y and B. Y and B. VR, VY and VV is represent your phase voltage of RY and V. So, VR VY and VV and VV is equal to phase voltage of phase voltage of phase RY and V. R, Y and V. We consider that fault take place in phase R. Okay, that's why I phase current R equal to IF. Okay, and IR is the summation of the phase summation of the zero sequence, positive sequence, and negative sequence current. That is represented by IR1, IR2, and IR0. Okay, so just right here the IR1, IR2, and IR0 IR1, IR2, and IR0 is a positive, negative, and zero sequence current of phase R. Okay. So IR2, IR0, equal to positive, negative, and zero sequence current of phase R. Positive, negative, and zero sequence current of phase R. Zero sequence current of phase R. Okay. Current R. Current of phase R. Now, how we can find out the fault current for the system? This system, how you can find out the fault current? Okay. So, First of all, mention here assumption. That means pre-fault alternator is operating at no load condition. Okay. Alternator is operating at no load condition. No load condition. Okay. That means VR, Vy and Vb is your phase voltage appears at the no load condition in phase R, Y and B. And what is the phase current of Y and B? That means at P fault, that is before the fault, the alternator is operating at no load. That means no current flow through the phase Y and phase B and phase R. Okay. So IR, IY and IB equal to 0. So IR equal to 0. IY equal to 0 and IB equal to 0. Y equal to 0 and IB equal to also 0. Is not IB also 0. But phase voltage VR, Vy, Vb APS across the phase terminals. Okay. After the fault take place, what will be changes? Just note down. That means fault current flow through the phase R. So just IR is just whatever the fault current flow that we will require to find out. So after fault take place, after fault what is the value of phase voltage R? Rahul? Hello? Hello? So fault take place in phase R, means this voltage VR will become 0. VR will become 0. So just right here. VR equal to 0 because fault takes place in phase R. Okay. And what is the current of phase Y and B? Same as the previous one, is it not? Because this one, this phase is also open, so no current will be flow through this phase Y and B. So IY and IB is also 0, is it not? IY and IB is also 0. IY equal to 0 and IB is also 0. IB is also 0. What is the value of phase current IR? That is equal to IF, you can write here, is not. That means for phase current IR equal to IF. Okay. Now we can represent the positive sequence, negative sequence current and zero sequence current in matrix form with respect to of phase current RYB. Okay. So just to find out the positive, negative and zero sequence current in matrix form. So let's represent that is IR0, IR1, IR2 equal to 1/3 of the IR0, the zero sequence current, positive sequence current that is represented by IR1, IR1 and negative zero sequence IR2 is equal to how much? IR2 equal to 1/3 into matrix 1, 1, 1 alpha, alpha square, 1 alpha square alpha into IR, IY, IB. So 1/3 matrix form 1, 1, 1, 1 alpha, alpha square intermediate alpha square 1 alpha square alpha. Alpha square alpha. Okay. Into phase current R, Y, and V in matrix form. So just write here IR, IY, IB. So IR equal to, you can write from this equation IF, is not. So just write here IR equal to, just write here IF current IR right here fault current IF, not IF. Or just right here IF in place of IR, simply just write here IF, that means fault current what is the value of IY here? 0. So just put here IY in place of IY equal to 0. Or you maybe first write down the IY. In the next step, you just put the value of IY and IB equal to 0. Okay. So IY IB. Okay. So now you can just put here the value of I phase current IR, IY, IB, whatever you obtain here after the fault take place. Okay, that means IR equal to IF, IY equal to 0, and I phase current B equal to 0. So just put in this equation and just solve for the IR, that means positive sequence current, negative sequence current, and positive sequence current, negative sequence current. Okay. Next step, just you put the value of phase current IY, IB 0. So this equation becomes just like again IR 0 IR1, IR2. So